Let's talk about a little domain and range. All right, you probably have heard of those words before in a mathematical context, and I'm just going to start a little out of context and just point to this bracket and say this means that it includes, and this means that it does not include. You could say exclude, which sounds like it, well, it's kind of a different context. But anyway, it does not include. And because you cannot count to infinity, never include infinity. That is the symbol for infinity. By the way, infinity is not a number. Infinity is more of an idea. Okay, just throwing that out there. Okay, domain are my x values. And make that a u. There we go. And range are the y values. And that is all you need to know to really start this lesson. You may not even know what the context is, but we're just going to go with it. And here we go. I need to know the domain and range of each graph, use both interval notation and inequalities. I'm going to start with interval notation. We'll do the whole front side with interval notation, and then we'll go back and do it with inequalities. Okay? So my domain, symbolized with the D, will be, okay, well, let's look and let's see. All right, as I look at this graph right here, which is a short little line segment, it starts here, it ends here. Well, where does it start and where does it end? And when I say where, in this context with domain, I'm referring to x values. So at what x value does this thing start? Well, let's look on the x-axis. Oh, -4. Okay, cool. -4, comma. And it ends here. At what x value does it end? 2. Done. Okay. So now we're not done because we've got to figure out how to close this thing off. This is going to start looking like a coordinate sometimes, but technically it's not. It's really a domain. It goes from -4 to 2, and this closed circle means that it does include -4. Well, if it does include it, then I put the bracket, and if it doesn't include it, I'd put a parenthesis. That'll happen here. Just throwing that out there. Okay, but it does include it because there's a closed circle. There we go. So my domain is from -4 to 2. My range is, okay, now what y values have I used? So no longer am I looking at this and saying, oh, what are my x values? Now I'm looking to say, okay, what are my y values? So I'm going from down here to up here. And when I say down here, my down here is at -2. And my up here is at +1, -2 to +1, brackets on both because they're closed circles. And that's it. Now we'll come back to this problem when we're done with the front side, and we'll write interval notation. I'm sorry, we'll write inequalities instead, but for now, we're done. Okay, so don't make it harder than it is. You just have to ask yourself, what x values am I using? What y values am I using? Okay, what x values do I use in this graph? Well, I use every x value from here to here. Well, now give me numbers for here and here. From this to this. From -2 to 5. What it really means is that every x value between -2 and 5, including both of those because of the brackets, every x value including -2 and 5 are going to be included in this graph. Like, okay, pick a number between -2 and 5. Well, 1. Okay, well, 1, yep, the graph is there at x equals 1. Pick a number between -2 and 5. 3, oh, 3, yep, 3 is there between -2 and 5. There's my graph. Okay, now my range. My range is going to go from, well, let's go from the bottom up. So from here to here, and here is -3. Here is 4. And there it is. All right, let's keep moving. My domain, my range. My domain goes from, well, I'm going to go look from left to right. So -1 to 2. -1 to 2. Bracket on both. Okay, what y values do I use? Now, here's where it gets tricky, because you might look at that and you might say, well, I'm going to go from, let's see, here to here. Oh, well, let's start here for sure. What is the y value here? Now you might be tempted to say -1 because you're looking at that number, but the y value on the y-axis is actually 0. So this graph goes from 0, including 0, all the way up to 3 and beyond 3. My graph goes from here to here. So it's not always the end points. In this case, it goes from down here at 0 to the y-axis going all the way up to 4. And because there's not an open circle here at the 4, or something we'll encounter later called an asymptote, then you're good. Don't worry about the word I just said. It's a word that we'll deal with later. Okay, the domain here, the range here. Okay, it's going to go from to boom. Let me use words this time. Starts at this x value, ends at this x value, -2 to 6. -2 to 6. Let's just jump to the y's also. It's going to go from -2 to 2. But this one is different. And you already know why it's different. But it's different because this coordinate right here isn't technically on the graph. That's why we have an open circle on it. So if I said, hey, what's the value of the function at -2? You'd say, oh, well, you know what? The function doesn't exist there, open circle, right? So it does not include an x value of -2. So parenthesis, not a bracket. Okay? The x value over here is 6, and there is a closed circle on 6, so there is a bracket. All right, the range goes from -2 to 2, but it does not include -2. It does include +2. Okay, let's do the next one, and now things are going to get a little tricky. The domain here, the domain goes from -3 to what? What's missing on this graph that you don't have to write is an arrow. It's implied. So it goes on forever. So the domain starts here at -3 and does include it. And it keeps going all the way, well, to infinity. And you can go ahead and quote Buzz Lightyear there if you like. Nevertheless, it goes just forever. It goes to infinity. So all the x values forever and ever are always used, and you never include infinity. So don't put a bracket on infinity because you can't count to infinity. So parenthesis on infinity, always. Okay, the range starts down here, looking at my y-axis. I see that -2, and it goes up. And it goes up and up and up, and it keeps going up. Now, it's going over, but I never say, oh, this is where it stops on the y-axis. It just keeps on going up, because if I could draw this graph forever, it would just keep on going. I'd keep going up, this thing keep going sideways, and no, it's never going to stop. So there we go. There's that. Okay. Domain, range on this one. This one starts at -3. And moves this direction. Now, I'm looking to see where it ends over here. Now, I know you're like, but it goes down, and no, don't worry about it going down. Here's what I'm doing. I'm looking to see where it starts. I'm looking to see how it goes. And it goes, and it goes, and it goes, and it goes, and it goes. So, starts at -3 and goes on forever. So, -3 to infinity. It does not include -3. Never includes infinity. Okay, now the range. It starts down here. Well, then it's down, but down here, down, but it goes down and down. Okay, here's the point of my stammering. It goes on forever in this direction, meaning that there is no y value that I could say, it starts down here and it goes up. Well, it's forever down. So negative infinity all the way up to 2. I'm looking at the y-axis, so negative infinity to 2. It does not include 2. never includes infinity or negative infinity. Okay, here we go. We have a parabola. This parabola has a domain, has a range. Let's do the domain first. Knowing that we have arrows that point like this, and even though it's going upward, it's continuing to move to the left as it goes upward. So again, I can't look at this and say, oh, well, it starts like right here, and it goes all the way over to here. No, it goes forever to the left, it goes forever to the right, and in that foreverness, it's negative infinity to infinity. Any x value you pick will be represented on this graph. Here, any x value you pick between -3 and infinity will be represented on the graph. If I pick -4, nope, no such luck, right? Negative infinity to infinity, yeah. If I say -6, well, -6 is over here, and the graph would be way up here somewhere. It works. The range starts down here and moves up, and it goes up forever. We can see the arrows pointing upward. So here on the y-axis is -3, and it goes to infinity. Never include infinity, but it does include -3. In this case, you might be like, well, how do I know to include it? You don't see an open circle or something you'll encounter in a few chapters called an asymptote, so you clearly don't see that now, so you're good. All right, this next one's much easier than you might think it is. Pardon my computer and its notifications. All right, domain, range. The domain in this case, let's see, it goes up forever, and it goes to the left forever. This is going left and up. So it's going left forever and up forever. And here it's going right forever and down forever. So as it is going to the left forever and to the right forever, it goes from negative infinity to infinity. And I can't identify where it starts and ends on the y-axis either. So negative infinity to infinity. Okay, we've done the front side, but now we're going to go back and finish what it asked us to do because it said interval notation and inequalities. So let's go back and do it again. And I know you're like, oh, really? Again? We have to? Yeah, but it's easy. Okay, check this out. Domain is x values, right? So I want all the x values between -4 and 2. So for my domain, I'm going to write these in red. My domain is going to be all the x's between -4 and 2. And I'll use inequalities, and anytime I use inequalities like this, and I say, oh, x is between them, I always use less than, for reasons that will become obvious in a lesson in a few days. Nevertheless, we'll use less than. And it does include -4, and it does include 2, so I'll put equal. So really, don't make it harder than it is. X can be less than 2, or equal to 2. I'm going to read this backwards. X could be greater than or equal to -4, and it's sandwiched in between those two. So this is my domain, and here's my range. Y values are between -2 and 1, so -2 to 1, and less than always. Don't be like, oh, I don't know when to use a less than and when to use a greater. Use a less than. Use a less than. If you're going to cram it between two numbers, use a less than. Trust me. And it does include both of them, so there you go. So these should be pretty straightforward. Like for the next one, my domain is representing x values. So it's going to be x when it's between -2 less than x less than 5. Cram it between two less thans. And then it is equal on both of them. These are y values. So there you go. I got a y value. I'm going to cram it between a 4 and a -3. Less than or equal to on both of those. Let's keep moving. These go pretty quickly. So x is between -1 and 4. Oh, sorry, 2. Change that to a 2. Clicking in the wrong place. That's bugging me. That is an ugly 2. I'm going to fix it. There we go. We do include -1, so it's equal. We do include 2, so it's equal. And I say we do include it because it's a bracket, and that's the first thing we wrote in the notes, right? Okay, the y values are between 0 and 4, less than, equal, equal. Okay, now things get a little different. The x's are between -2 and 6, less than. It does not equal -2. It does not include, so don't put equal here, but I will put equal here. And on this one, It's the y values. It's between -2 and +2, both less than. It does not equal -2. It does equal +2. Okay, and up to this point, it's pretty straightforward. These last few that have infinities in them are going to be a little bit different. So let's slide up to this next one. And let's actually look back at the graph to really gain an understanding of what to do with this one. So in this case, x is not between anything, because you could be like -3 to infinity. And well, infinity, don't put that in inequality. That's just ridiculous. Basically, every x value that's greater than -3 is going to work, right? So let's just write that. X is greater than -3. And because it does include -3, we'll do that. Okay? Every y value greater than -2 works. And I'm looking at the y-axis and kind of sliding my eyes up as I see that. I go from -2 upward. So y is greater than -2. Oh, but it does include that. There you go. See? Not so bad, is it? In this case, x is greater than -3. See? Goes greater than -3, but doesn't include it. And in this case, y, I can't go like zoop. Instead, I have to kind of go down, and it makes sense here. It's like -infinity to 2. So it's everything less than 2. So in this case, y is going to be less than 2. Okay, so I know I said always use the less thans. I mean that when you're cramming it between two numbers, like, oh, y is between 0 and 4. Well, then use less than. But in this case, y is less than 2, or x is greater than -3, and I don't put equals on either of those. Okay, in this case, you could be like, well, everything works. Then say that. X is all real numbers. That looks like all real hashtags or pound signs, but it means numbers. And then the y is everything greater than -3, and it does include it. Let's do one more. X is all real numbers, and then the y, we'll put colons after that just to kind of break it up grammatically. It's all real numbers.